Good morning, all of you, and let's try this problem. And it's a nicer one in the sense like we have to analyze in all the four quadrants. The question is evaluate and simplify for all x belonging to 0 to 2 pi this expression sine to cos under root 1 minus t square dt. Now one way of doing this is probably a typical substitution of t equal to sine theta, and then we can use, or you can directly use the formula x root over 1 minus x square by 2 plus a square by 2 sine inverse x, okay, and then plug all these values and analyze in different quadrant. But probably the better way will be to use fundamental theorem of calculus, which is Leibniz rule, as you will often know. So we'll find f dash x. So we'll put cos x in this function. So 1 minus cos square x, as you can see in this step. And then we'll differentiate cos x, which is minus sin x. Similarly, we'll put sin x in this function, root over 1 minus sin x square x, and we'll differentiate sin x. So finally, we got minus sin x, mod sin x, which is very crucial part of this problem, because what's crucial is root over x square is mod x in general, right? It takes care of all possibilities of positive, negative, and being 0. So now if x belongs to the first quadrant, which is x belongs to 0 to pi over 2, so mod sin x and mod cos x will just open as sin is cos, so we'll get minus 1. In second quadrant, mod sin x will open as still sin x, but cos x will open as minus cos x, so we'll get cos square x minus sin square x, which evaluates to cos 2x, as you can see over here. In third quadrant, similarly, we'll get 1 and minus cos 2x. So that is f dash x will be 4 possibilities, and all are different possibilities. So hence f of x I'm getting to be minus x plus constant. So if I integrate minus 1, we'll get minus x plus constant. In first quadrant, half sine 2x in second, x plus c3 in third, and minus half sine 2x plus c4 in fourth. Now from the definition, we know f of pi by 4 has to be 0, because if I'll put pi by 4, I'll get 1 by root 2 to 1 by root 2 of something. So the area bounded from a to a is definitely, I'm not sliding anywhere, so it will be just a line with 0 area. So that gives me boundary condition. So at pi by 4 we'll get 0, so the value of c1 is pi by 4. Likewise, we can find the value of c2, c3, and c4 also. Equal to pi by 2 will give value of c2, which is minus pi by 4. Similarly, from continuity at 3 pi by 2, because from this junction I can get a continuity which will give c2. Again, I can apply the continuity idea on this junction in second and third quadrants at 3 pi by 2, right? And we can use continuity idea again at this junction to get the value of c4. So summing in total, the value that you will get is, so in total f of x behaves like between 0 to pi by 2, as you can see from the graph, is a straight line. In the second quadrant, from pi by 2 to pi, it behaves like half sine 2x minus pi by 4, so this branch of curve will come into picture. Similarly, at x minus 5 pi by 4 till 3 pi by 2, so till 3 pi by 2 again is a straight line. And in the fourth quadrant, it's minus half sine 2x plus pi by 4, so which goes like again a curve. So this is a beautiful curve which I'll getting this function sin x to 2. Now many questions can be framed on this, because JE can give this function f of x and maybe some circle passing through origin with a particular radius. They can ask you for number of solutions, or they can ask you for minimum distance or maximum distance between any 2 points on this curve. So if P and Q are 2 points, say P belongs to this and Q belongs to this, so we can find the maximum distance probably in the extreme conditions they are at the endpoints. Okay, so those can be the formulations of the problems over here. If you are enjoying these videos and these unique problems, please do like and subscribe the channel for more quality content for free.